So now in this video we're going to look at two important voltages for this circuit here. So we got an NPN bipolar junction transistor, and with the help of a capacitor, it turns the LED on fully when we press the button, but then when we release the button it takes a while for the LED to turn off, and it fades down after it starts turning off. So we have about 0.6 volts across the capacitor because of the base to emitter diode drop. The capacitor can't fully discharge, or it will take a long time to trickle through. And this voltage is the collector up there. So we have 5 volts on one side of the LED, and if we had 0 volts, then it would pass the full current that it can. But we instead have the transistor off, and so it's pulling up that voltage. You know, it looks like about 3.5 volts there. 5 volts plus the 1.5 volt diode drop of the LED. So now we press the button, the capacitor charged almost instantly. It has a resistor that limit current a little bit, but it charged up to 5 volts really rapidly, and now we got that 0 volts. The transistor is conducting to ground right there, 5 volts across the LED. Capacitor is discharging. Once it gets close to 0.6 volts, not as much current goes through the base to emitter, and thus there's less collector to emitter current. The LED fades down, and once it levels off, it's pretty much fully off, although a little current may be trickling through. And the capacitor again discharges about 0.6 volts because it takes about 0.6 volts for current to go from base to emitter, so it'll stop discharging at that point.